Hi, welcome to Dissolve Chemistry. Uh, Dear students, in the last video, we have started our discussion on these basic concepts of chemistry. In that, we have discussed regarding a definition of the chemistry and what is the importance of the chemistry. Okay, and for what reason we have to study the chemistry, right? So, in the present video, we will discuss regarding nature of the matter. Okay, in that first concept, we will discuss physical states of the matter and then followed by that classification of the matter. Okay, so that we will discuss in one by one. So first thing is physical states of the matter. See here, matter is going to exist if you see in and around us. Say for example, I am holding the pen. Physical state of this pen, if I ask, then you will say that it is a solid state. Okay, it is a solid substance. Like many solid substance you observe in and around you, and continuously you are respiring, isn't it? You are alive because of that reason. So therefore, you are taking air, inhaling air, and you are exhaling. So therefore, gas is existing. And if you feel thirsty, you are going to drink water, which is the example of the liquid form. Means we come across with all three different types of physical states we are going to observe of different matters. Okay, and dear students, as it is going to exist in three states, what these three states are, how they are different from one another. Okay, what importance they have in their different state and how we can convert from one state to the other state. Okay, so we'll go in detail with that. So as I already have mentioned that matter is going to exist in three physical states, that is solid, liquid and gas. The difference, major difference what we find in these three states of any matter is that in the solid, they are more, intermolecular forces are very strong. So therefore constituent particles are held very strongly and more compactly packed. Okay. And in the liquid state, what we see that the intermolecular forces are moderate and not much as compactly they are packed as solid, but still they are very close to one another, right? Comparatively, when you compare to the gas, and they are loosely held than compared to the solid. Okay. Then next is gaseous state. In the gaseous state, intermolecular forces are negligible. Okay, so intermolecular forces are negligible means it is almost like no forces we can say. Means molecules or constituent particles are independently migrating or they can move in any direction. Okay, so that is what is the different states what we have discussed based on intermolecular forces. Now, how we can convert these physical states from one state to the other state? One generalization you should remember, any matter can be brought which you imagine that it is going to exist always in the form of solid or always in the form of gas. It is not like that. We can convert any matter which is in the form of gas, which we visualize, into liquid as well as solid, and in the same time we can convert solid into, say for example, iron. Generally we have perception that it will be in the form of solid, but we can convert that into liquid as well as in the form of gas also, but it happens at very high temperature. Why I am using this term called temperature? What is the role of temperature? Okay, so we'll go in detail with that. See here, in the solid, the molecules are more compactly packed because of what? Strong intermolecular forces. Okay, each constituent particles are held together by very strong forces. So therefore, more compactly packed, right? And they become a rigid mass. Now, how I can convert this into liquid state? So just if you give energy in the form of heat, means if you raise the temperature, then what happens? Appropriate temperature, then they will convert into liquid state. Then what this temperature will do? See here, heat energy absorbed will break the intermolecular forces. Okay, so it will break the intermolecular forces, hence it will convert into liquid state. And further, if you heat and raise the temperature, then what happens? Still more intermolecular forces are broken and converted into gaseous state. Then next, how to convert gas to solid state? So just what you do, you remove that energy in the form of heat. Okay, or we can call it as what? Decrease the temperature. Then it will condense back to the liquid state, which will freeze into solid if you lower the temperature as. Means In one direction, if you go on rising the temperature, you can convert from solid to liquid to the gas. Okay. And in another direction, if you remove the temperature or if you lower the temperature, then what happens? You can convert from gas to liquid, liquid to solid state. Okay. So this can be done. Then we can generalize that these two forces, that is intermolecular forces and temperature, are acting in opposite direction. Intermolecular force wants to keep the molecules intact, and temperature, raising the temperature, leads to what? Breaking of these intermolecular forces. Okay, make note of that. So in the solid, strong intermolecular forces, if you raise the temperature, it will convert into liquid. And liquid, if you still more raise the temperature, it will convert into gas. And conversion of solid to liquid is called melting. And liquid to gas, we call it as what? Boiling. And there are some solids which can directly convert from solid to liquid. That we call it as what? Sublimation. This also you should make note of. Sublimation. Okay. You can take example. Best example is your what? Camphor. Okay. So which is going to sublime, and iodine is there. That is also subliming solid. And you can take your naphthalene, mothballs, what we call. That is also subliming solid. So then gas to liquid, condensation we call, and liquid to solid we call it as what? Freezing. Okay. So this is all general aspect. Then what are the characteristic property of the solid? So solid, in that already I have said that intermolecular forces are very strong. So therefore constituent particles are more compactly packed. Okay. To make it a rigid mass which will be very hard. Okay. And it gives a tensile strength to the matter. Right. And liquid means what? The intermolecular forces are moderate. For still molecules are held together with one another. Okay. And they don't have definite shape, as even these solids are having definite shape and size and mass. Similarly, they are having definite what? Volume they have, but they don't have the definite shape. They will take the shape of the container. If you pack it in a cylinder, it will be having cylinder shape. Or if you take it in another container, it will take the shape of that container. Okay. That is all about liquid state. Then gaseous state, here molecules are more independent, means they are not dependent on one another or being held by one another. So therefore they are independently migrating, right? And these gaseous molecules, they move randomly in all the directions. Okay. They don't have any direction to move. So therefore there is a lot of collision we are going to observe between the gas molecules. And you should remember the reaction is very rapid in the gaseous phase because of random motion of the molecules, right? And another important aspect what you have to make note is the flow of gas is going to take place from high pressure to the low pressure. And similarly, even liquid, on point I have missed that you can include that in the liquid, they also have the flow, but that happens from what? In the direction of the slope, it is going to move rapidly. Okay. So this and solid, there is no, what you call, it is not having any mobility. Okay. This is all about different physical states of the matter and how they are going to exist and how we can bring the change in these physical states. Okay. And what forces are playing important role and what are the characteristic properties of the solid, liquid and gas. I hope you have understood the physical states of the matter. Okay. Thank you for watching.